Hello, everyone. Welcome to the MEMS Oral History Project that is sponsored by the IEEE MEMS Technical Community. My name is Jack Judy. I'm a professor of electrical and computer engineering at the University of Florida and the director of the Nanoscience Institute for Medical and Engineering Technology. With us today is Dr. Masayoshi Esashi, who is a professor emeritus of engineering at Tohoku University. Dr. Esashi received his BE and PhD degrees in electrical engineering from Tohoku University in 1971 and 1976, respectively. He is recognized as a global leader in the field of MEMS. In fact, he was given the IEEE Andrew S. Grove Award in 2015 for developing MEMS used in transportation and industrial electronics. In 2016, he was also given the IEEE Junichi Nishizawa Medal for advances in material science and device technologies. Dr. Esashi, thank you for taking time today from your busy schedule. We look forward to hearing what you have to say.
Thank you, Professor Judy. It's my great honor and pleasure to have this opportunity.
Let's begin with a discussion of your earliest years. Can you tell us when and where you were born and share some memories of your early family life?
Let's see. I was born in Sendai, and I have been studying and working in Sendai until now. I left Sendai only 3 months. I stayed in Sweden, Linköping, for 3 months. And when I was a kid, I like to make, for example, plastic model and so on. So, and I was very interested in the circuit.
Oh, I see. So what was it like growing up in Sendai in the early 1950s?
1950s?
Yeah, when you were a little boy,
Yeah.
what was it like? Was it a big city, or was it much smaller then?
Medium-sized city. And at that time, we have U.S. camp in our city.
A U.S. camp, the military?
Military camp. Yeah.
Oh, okay.
And that camp is now campus of university, Tohoku University.
Really? Wow.
And I have been enjoying my life. After high school, I entered Tohoku University, faculty of engineering.
Before we go to your university years, I still want to learn more about your primary school or high school. You know, what kind of student were you, and what kind of subjects did you like the most when you were a little boy in school?
Yes, I like baseball when I was a kid.
Okay.
But I have some problem of blood. So I think I was not so good at sports.
I see.
And I have been interested in making things. For example, circuit using vacuum tube, and in high school using transistor. So I was good at to make circuit.
Ah.
And
Can you tell?
okay.
Yes, please go ahead.
And in Tohoku University, I was in electrical engineering. Electronic engineering. And my supervisor was Professor Matsuo. He was good at electronic circuit. He stayed in Stanford University.
I see. So going back to your family, can you tell us about your parents? And did you have any brothers or sisters?
Yes, I have brothers, 3 brothers. And including me, 4.
What did your father do?
My father is a medical doctor.
Oh. Did you ever think that maybe you wanted to be a medical doctor?
No. I like engineering. No, my brothers all don't go to medical school.
I see. All right. So besides baseball, was there anything else you would do for fun with your friends in high school? Any hobbies? You said you built radios and things. That sounds like something maybe you did by yourself. Did you do things with your friends?
Yeah, I belongs to a circle of amateur radio communication and physics.
I see. Great. So, were there any early events or mentors that influenced you towards science and technology, or was it simply, like you're saying, just your own interest? You just already had this interest. There wasn't someone who strongly encouraged you or mentored you as a child?
In high school, my colleague made equipment. It's a transmitter, radio transmitter, using a vacuum tube, and I enjoyed. And he taught me many things.
I see. Yeah, that's an important influence. So you said, I guess it's clear why you decided to study electrical engineering for your undergraduate degree, because of your interest and your support of your colleague. Can you tell us anything about your time in college as an undergraduate student working towards your bachelor's degree?
In bachelor's degree, I entered the laboratory of circuit. And when I was a master course student, I helped some students in Professor Nishizawa's laboratory. Professor Nishizawa was very famous in semiconductor. And I made a CV measurement system for his student. And since it's a good opportunity for me, because I I could use his laboratory, Professor Nishizawa's laboratory, and there were many homemade equipment for transistor, for semiconductor.
I see. So it sounds like you made some circuits to improve the measurement of CD. I'm sorry, did you do that in your bachelor's, in your fourth year, or did you do that in your master's?
Master course.
Ah, master course.
Mm.
Okay. So, okay. Did you do any research as an undergraduate for bachelor's degree? Any research?
Yes, some research, but undergraduate course, not so much.
Right. I see. So, did you, some of your friends, when you worked towards your bachelor's degree, might have, when they finished, gone to industry to get a job, but you decided to go to get a master's. Was that common, or was that rare?
About half of students went to master course.
I see.
And
So, yeah.
I was requested to go to Toshiba because my supervisor, Associate Professor Inuma, developed ultrasound imager for medical use, and I was requested to join his group, but because of help by Professor Nishizawa, I decided to go to doctor course and made equipment for semiconductor devices.
I see. So then you joined his lab, Professor Nishizawa's lab, for your doctorate.
My laboratory was Professor Matsuo's laboratory, but because I helped the Professor Nishizawa's student, I could use the facility of Professor Nishizawa, and there was many homemade equipment for semiconductor, and I could learn.
Okay. What was the focus of your doctoral thesis?
Yeah. I developed ISFET, ion sensitive field effect transistor. Yeah.
Oh.
Yeah. Can you see? Yeah. The gate metal is removed, and it is exposed to electrolyte. And this could be used ion sensor. And I made a probe using MEMS technology for catheter.
Really? Was that your earliest experience with microfabrication?
Yes. But I wrote only one paper when I was a postgraduate student for ISFET because I made the equipment by myself.
That's a lot of work.
But it's very it was very good for me because I could have small flexible equipment for prototyping semiconductor device.
I see. So you were involved in microsensors at a very early stage.
Yeah. More than half century ago.
That's why many consider you the father of MEMS technologies in Japan. So that's very pioneering work. Now, I see that you finished your PhD and then you decided to stay at Tohoku University as a research associate.
Yes.
Why did you decide to do that?
Yeah. My professor requested me to stay in his laboratory.
Oh, okay. Why did he request you to stay? Did he thought you had lots of more exciting research to do and you liked doing it, so you stayed?
Yeah. Yes.
Yeah. So it seems clear you clearly liked research and exploring ideas, even from an early age.
Yeah. I was very happy.
Yeah, sounds like a good fit.
And
So
and
yeah, then please.
sorry. Yeah. In Japan, Professor Dr. Isemi Igarashi, he is a pioneer of pressure sensor. He was in Toyota Central Research Laboratory, and I was influenced by him very much when I was a student, postgraduate student. I was a postgraduate student and research associate.
I see. Yeah, I was going to ask you about other mentors you had in graduate school or postgraduate. It sounds like he played a very important role.
Yes.
I see. And then you stayed at Tohoku University, as we've established, and went on to become associate professor, and then eventually full professor at Tohoku University. Can you talk about what it was like as a beginning researcher and associate professor? Was there a lot of funding? Was it challenging? What was it like when you were a junior professor?
Yeah. When I was associate professor, I moved to laboratory of computer.
Oh.
And requested to make integrated circuit using homemade equipment. On
Homemade equipment.
Yeah, 20 millimeter square silicon wafer.
20 millimeter square wafers.
Yeah.
Homemade equipment. Wow.
Yeah.
Homemade oxidation furnaces, diffusion, the whole bit. That's very resourceful. The Japanese and universities at that time.
Yeah.
Resourceful.
Yes.
Okay. And then let's see here. You've also became the director of the Micro Nano Machining Research and Education Center at Tohoku University. Was this your research lab, or was this something else?
When I became a professor, I moved mechanical engineering group.
From computers to mechanical.
Yeah. So I was very happy because I have experience of medical device and electrochemical sensor and computer, integral circuit, and pressure sensor and so on. So
no wonder you did MEMS. Your training was so broad.
Yeah. I enjoyed.
Was it broad because you were always so interested about other areas, or you just said, oh, I want to learn this electronics and build circuits, and I want to learn mechanics? Are you always pursuing new directions, or is this something that you did mostly during your early professorship?
I was requested to move to a computer laboratory or mechanical group, and I think it's good to learn new things.
But I find it interesting. Who requested that you move to computers or move to mechanics? It wasn't your decision. Someone else
No, not my decision. Someone else.
Very curious. Well, I guess it was a wise decision, a good fit for you.
Yeah. So I have been very happy.
Yes. Now, yes, you've also been the associate director of the Semiconductor Research Institute. Can you tell us a little bit about that?
Yeah, Semiconductor Research Institute, it was established by Professor Junichi Nishizawa. And I'm now in his building. His research institute was closed in 2008. And some years ago, he passed away. And the building and other land and so on are donated to university. And we use the facility. And in that facility, there are big clean room, 1,800 square meter clean room. And there are all the process equipment for MEMS and semiconductor devices.
Wow. So did you inherit that space and managed it?
Yeah. I retired 10 years ago. And the successor, Professor Kentaro Totsu, he is managing. And I'm supporting him.
Right. Now you're doing that. But you inherited it from Nishizawa. Yeah, I see. Let's see. Now, is it true that a lot of research was done in collaboration with companies? Did you have a lot of industrial collaborators or partners in your research?
Yes. In our laboratory, many companies dispatched their researchers. 130 companies dispatched their researchers, and in average 2 years they stayed. And many competitors, for example, Toyota, Daimler, Ford, they collaborated in our laboratory. And they stimulated our student. And our students are motivated by them.
Did I hear you correctly? You said 130?
Yes.
Wow.
Companies.
That's amazing. That is amazing. Let's see here. Now, I also understand that you were the director of the Venture Business Laboratory at Tohoku University. What was that like?
Yeah. Government requested university to have startup companies and supported us. So we could build the facility. And in that building, we have a facility for 2-inch silicon wafer. And the facility was shared by many laboratories and many companies.
I see. So it was an additional laboratory beyond what you used. I see. And others could use it. I see. Now, you were also president of the Sensor Machine Society in the Institute of Electrical Engineers in Japan. Were you an active member in your technical society?
Yeah, before I was active, but not now. Because I was sick before, and so I couldn't attend the MEMS conference or transducer. It's since 15 years ago, I couldn't participate.
I see.
But I recovered by
Great. Good to hear.
transplantation of bone marrow.
Oh, wow.
Because
Glad that worked.
so now I'm fine. I'm healthy.
Yes, well, we missed you today at Transducers 2023 down in Kyoto, but it was a very good meeting. Satoshi Nishi did a very good job. Hey, so let me see. I'd like to ask you about MEMS conferences. You mentioned that your health prevented you from traveling for quite a while. When was your first MEMS conference?
Yeah, it was in United States, near Pennsylvania. We have a meeting, and I visited when I was about half century ago. At that time, I visited Professor Shockley in Stanford University.
Really?
On the way back.
That's a long ways back. So I see, and so your first was 87?
First meeting? Sorry, I don't remember. It takes time to find the
Yeah.
exact.
Yeah, I'm sorry. I maybe I have it maybe a mistake, but yeah. And then I recall you were the general chairman of the MEMS conference in 1991.
Yes, in Nara.
Nara. That was a very good meeting. I think that was my first MEMS meeting.
Oh, really?
Yes.
I and Professor Fujita chaired.
It was a great meeting. It was very inspirational. I learned a lot.
It's very nice.
Thank you for doing that. And then of course we held Transducers 1999.
Yeah.
In Hyundai. Yeah, that was also another very good meeting.
I think Transducer 99 was the 10th anniversary. And we had sample exhibition there. And we have now exhibition room, MEMS exhibition room here, because of using that samples.
Yeah, so your first MEMS conference in Philadelphia, that was very inspirational to you. Do you have any early impressions about some of the work that was presented there? Do you remember anything from that first conference?
Yes, yeah. Many MEMS pioneers were there.
Right. So, indeed, were there other people beyond the ones you've mentioned already, perhaps in the MEMS field, that that you collaborated with, or perhaps mentored you as well?
Collaborated with? Sorry.
Oh, sorry. The people these pioneers that you met at the first conference and their papers, did you collaborate with them, or did you interact with them and get some good ideas?
Yeah. Do you know Professor Weiss in Michigan?
Yes.
He was in Stanford University when my supervisor, Professor Matsuo, stayed in Stanford University. Professor Mindl's laboratory.
Ah.
And after that, I visited Professor Wise several times. And for example, Professor Wenko, there are many professors.
I see. Now, you've had many research projects, but I wonder, when you look back at your research career, are there any projects that come to mind that you are particularly proud of or fond of?
Yes. Because we accepted many researchers from company, they have needs, and we worked together, and many devices are commercialized. MEMS switch, MEMS mirror, electrostatically levitated rotational gyroscope, and so on.
Yes. Well, yeah, that's wonderful that you had those industrial collaborators that could take the successes from your collaboration with them and commercialize them. You had a wonderful situation there.
Yes, I think
quite
so.
Quite unusual. So that was very good. Now, if instead of looking back, if we look forward, are there any challenges or opportunities in the field of MEMS today that you think are very, very interesting or exciting, and that you look forward to being advanced by others?
Yes. So now, for example, in universities, there are the very advanced papers. To write advanced papers, we have to learn a subject deeply. But for MEMS, we have to have wide knowledge and the experience of fabrication and so on. So I have been interested in how to access so various wide knowledge.
I see. Yes. In fact, if you were a student today, which area of study or research do you think you would pursue now, given the situation we're in now?
I see.
Can you imagine if you were a student now, starting over?
I see. I say Professor Nishizawa was very happy because at that time semiconductor device started. But now, especially in university, it's very hard to study semiconductor. It's in MEMS field is also difficult to develop new MEMS devices.
Yeah, it is challenging, but people are still. The conference this past week at Transducers 2023 was very good. We saw a lot of exciting work, so people are still coming up with good ideas. Do you have any hobbies that you do outside of your work with engineering? That you do for fun, maybe when you were a professor, or even now when you're retired. Do you have any hobbies?
Hobby. I have not so good hobby, but I enjoy my life because I can support my successors. And I also belong to a company, MEMS Core, in our city. And this morning I was in our company, and it's a development company. So there are many things to contribute. So I'm very happy.
I see. Well, it sounds like you might have retired from the university, but you haven't retired from work.
Yeah, yes. I can help young people.
Yes, well, they keep you inspired and engaged, I'm sure.
For example, you can see many files here. Here.
Yeah, what are the files on the shelves?
Yeah, there are 1,000 files, and it is can be accessed by keyword using Excel. So,
Really?
for example, some person in company or young people come to me to ask, I can find papers soon.
Wow, you've completely organized all of your information.
Yeah. It's my hobby.
You're ready to solve any problem. You have the information you need. That's wonderful. Well, Professor Esashi, thank you so much again for taking time to be with us today and sharing your stories about your impressive career.
Thank you very much.